there is a risk of what we call proliferation in the nuclear fuel cycle, in nuclear energy, and that is taking the technology and misusing it, and for example, using it to build weapons. And if you go back historically, the separations processes, the processes that were developed to break the fuel down into its components, were done in order to separate plutonium for weapons. That was a focus. So what we're doing is looking at technologies and systems that would prevent that proliferation or the misuse. And so what you want to do is, for example, make the material more difficult to handle so that you can't just take it away. It's highly radioactive, for example. We're also looking at systems where if somebody were to divert the material from the normal set of equipment, the normal patterns, it would be immediately detectable, so there's no time to remove that material. So there's a big focus on that aspect of nuclear. We've actually come a long way. There have been technologies developed not just in the United States, but also outside of the United States that are what you would consider the next generation. So in the processes that the United States is focusing on, we do not separate plutonium by itself. That's a proliferation risk, having plutonium separated by itself. So we're looking at processes that include other material, other parts of or other components of the used fuel. But one of the things we're being asked to do is take a step back and say, okay, if there's not an urgency to doing this, if we can wait 20, 30, 40, 50 years, are there processes out there that can be developed that could do a lot better, that could really give us benefits way beyond what we currently envision with processes under development? We call those grand challenges.